All right, students. Unit 10, the solar system. Lesson 4, the terrestrial planets. Um, where does all the energy in the sun come from? Well, I guess I forgot to edit that from last time. You know how I make mistakes. Um, Solar system, once again, this is incredibly interesting to me. This is something that your generation is going to find out a lot more than I will. Your children are going to find out a lot more than I will because we are really advancing in the solar system and going out there and understanding and learning more about this. So, as we look at this, our wonderful SOLs. Now, before I go into all of this, this is a very this is a very important concept that we're about to see. When we learned about the atoms, the ratio between the nucleus and the electron, there's an amazing amount of empty space when you think about it inside of an atom. Electrons are not right next to the nucleus, even though they're incredibly small. The distance between them, if you were that size, is incredibly immense. Um, the solar system is the same way. There is a immense amount of nothingness out there. This is the reason why we don't have things running into each other all the time. And I love this video because it gives you the concept of how much empty space is out there. And when I say empty space, this is does not have atoms in it, does not have air. It is just nothingness out there between the solar bodies. Now, we are going to learn that there are a lot of asteroids. There's a lot of things in the Oort cloud, but they're incredibly stretched apart. There's an incredible amount of nothingness in the solar system. And I thought this was a great video, and I want to show it to you before we start talking about the planets.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. Taking the same concept, but for the solar system, every single picture of the solar system that we ever encounter is not to scale. If you put the orbits to scale on a piece of paper, the planets become microscopic and you won't be able to see them.
Like atoms.
There's literally not an image that adequately shows you what it actually looks like from out there. The only way to see a scale model of the solar system is to build one. Welcome to Black Rock Desert. This is Alex. I'm
Hi.
Wiley. He's going to be behind the camera. I'm going to be probably making a lot of mistakes on camera. We have 36 hours to measure the distances, trace out the orbits, and set up a time-lapse shot from up on top of a nearby mountain. To create a scale model with an Earth only as big as this marble, you need 7 miles of empty space. So that's why we're here.
Why did you guys come?
I don't have a job.
At this scale, the sun is 1.5 meters, so about that big around. So we are driving right now to Mercury, and we've arrived. Venus is the same size as Earth. I have the world in my pocket somewhere. And this is Mars. Got a couple of robots rolling around on that one. Once the time lapse is ready, we'll drive each orbit with a light. Hopefully you'll be able to tell just how big they really are. Onward to the outer planets. Jupiter. Saturn. That tiny light out there is our sun, just over a mile away.
So that's how the sun would look in the sky from Saturn. It would just be a tiny dot.
The sun's way, way out there now. So this is it. This is the edge of the solar system.
So right now, it's about 7 a.m. We just woke up right before the sun's about to rise. We are on the Earth's orbit. Wiley is over there holding our sun. Cue the dramatic sunrise music.
So if we've made our model correctly, your perspective from where Earth is on the model will match your perspective from standing on the real Earth. So if you look back at the sun, you will see that the model sun and the real sun are the exact same size. And that's how you can tell that the proportions are correct. There are 24 people in the entire history of the human species, billions of people, who have actually seen the full circle of the Earth with their own eyes.
Following the breakfast, the astronauts went to the suit room where they donned their spacesuits.
This is man's attempt to get to the moon.
0. We have liftoff. Liftoff at 7:51.
In Earth orbit, the horizon is just slightly curved. When you head on out to the moon, that horizon slowly curves around and upon itself, and all of a sudden you're looking at something that is very strange, but it is very, very familiar.
Oh my God, look at that picture over there. Wow, is that pretty?
You can put your thumb up, and you can hide the Earth behind your thumb. Everything that you have ever known, all behind your thumb.
Not any bigger than that, way up there.
It's really beautiful. You can cry.
That's what I really wanted to try and capture. We are on a marble floating in the middle of nothing. When you sort of come face to face with that, it's staggering.
All right, students. So we are going to talk about the first four marbles floating in nothing, the terrestrial planets. And the terrestrial planets are closer to the sun. We are actually on a terrestrial planets. They are four small planets, dense, rocky planets, inner planets. We have a crust, a core, a mantle. Now, we measure height in meters, weight in kilograms, temperature in Celsius. Well, planets are measured with astronomical units. The astronomical unit, 1 AU, is the average distance between the Earth and the Sun. It's about 150 million kilometers. This is the measuring stick when we talk about how far, you'll hear it used talking about how far planets are from each other. So, terrestrial planets are the 4 planets that are closest to the sun: Mercury, Venus, Earth. This is a satellite of the Earth, the Moon, and Mars. Solid inner core, liquid outer core, um, crust mantle core. These are heavy materials. When these planets were formed off of solar nebulas, the heavier materials were closer to the sun, and that's one of the reasons why they feel that we are terrestrial planets. So, the rocky planets, let's give this a quick listen.
If you're packing for a trip to Hawaii, chances are you're gonna bring some stuff like a bathing suit and shorts, a few t-shirts, and flip-flops. And you're good, buddy? Me, of course. But if you're going to Antarctica, your suitcase probably looks a lot different. You'll need more layers, a big heavy coat, a scarf, gloves, all of the warm, fuzzy things. But what if you're traveling to Mercury? What do you need to pack for that? Okay, a spacesuit, yeah, but let's just pretend we could just walk around on Mercury like we do here on Earth, without a spacesuit. What kind of weather would we be dressing for? We know there's weather on Earth, and the fact is there's weather on other planets too. Some of it's familiar, like wind, but some of it is a little more, well, extreme. So what is the weather like on other planets? Well, before we leave Earth to find out, can I get a reminder of what exactly weather is again? Oh, right. Weather is the condition of the atmosphere on different parts of a planet. Even though there's only one atmosphere on Earth, the weather isn't the same all over the world. There are many different factors that can change the atmosphere in a certain area, and together they determine what the weather is like from 1 minute and from one place to the next. These factors include temperature, humidity, wind speed, and direction, and lots of other things. But when you're talking about the overall weather patterns for a certain region of the world, you're talking about that area's climate. Weather is the minute-by-minute changes in the atmosphere. Climate is what the weather is like over a long period of time in a specific area. Okay, got it. You know what else has got it? It being weather and climate. The other planets in our solar system. And let me tell you, there are some freaky weather situations happening up there. So, why don't we take a trip to each planet to see what they've got going on weather-wise? Let's start with those that are closest to the sun: Mercury, Venus, and Mars, otherwise known as the rocky planets. Which, by the way, is a pretty sweet band name. These 3 planets all have one thing in common with Earth. They're all solid worlds with hard, rocky surfaces that, if you ever went there, you could stand on. Let's take a virtual trip to each one to see how hot, cold, windy, or whatever these 3 planets are. First, hello, Mercury. Or should I say, brr. If you were thinking Mercury would be a super hot place because it's the closest planet to the sun, well, you're half right. Mercury is the closest planet to the sun, but it's not actually the hottest. Temperatures on Mercury can go from a super chilly 170 degrees below zero at night to a very warm 425 degrees Celsius during the day. Why the extreme changes? During its rotation, when one side of Mercury is facing the sun, that side gets super hot. But Mercury doesn't have a lot of gases around it like the Earth does. Without these gases to hold in heat, the planet can get really, really, really cold too, especially on the side that's facing away from the sun. So the planet's proximity to the sun, combined with its thin atmosphere, give Mercury the biggest changes in temperatures of any of the planets. Things get even more extreme on Venus, the next closest planet to the sun. We've sent probes to Venus to take pictures of what it looks like, and they show us that the planet is rocky and covered with thick clouds, but it doesn't have any life on it because Venus is extremely hot. In fact, even though it's not the closest to the sun, Venus is the hottest planet in our solar system, with temperatures reaching as high as 460 degrees Celsius. Why is Venus so hot? Because of something called the greenhouse effect. The greenhouse effect is what happens when light from the sun hits the surface of a planet and warms it up. That heat tries to bounce back into space, but a gas called carbon dioxide traps a lot of it around the planet, keeping it warm. It's sort of like what happens inside your car when you keep your windows up on a hot day. Oh, and next time you complain about it raining, you should know that it rains sulfuric acid on Venus. Yeah. Instead of water, Venus's clouds are made up of corrosive sulfuric acid. That burning acid doesn't reach the surface though, because Venus's toasty temperatures causes the acid to evaporate before it has time to hit the ground. So, yay! Okay, let's cool off and head to the next and final planet for the day: Mars. The red planet is known for brewing up some serious dust storms. Earth has dust storms too, but not like the ones on Mars. On Mars, a dust storm can get pretty intense in a matter of hours and take over the entire planet within a few days. A lot of Martian dust storms actually come from the same place, Hellas Basin, the name of a deep crater on Mars. The crater was formed billions of years ago when a huge asteroid hit the surface of the planet. The crater is filled with dust at the bottom, but the temperature at the bottom of the crater can be 10 degrees cooler than the temperatures at the top. This difference in temperature creates wind that picks up the dust, which then creates a storm that takes over the basin and then the planet. And you thought your room was dusty. After all these high and low temperatures, acid rain, and dust attacks, I'm ready for a good old-fashioned thunderstorm. So let's head home to Earth. And now you know what to pack if you ever have to take a trip to Mercury, Venus, or Mars. You gotta prepare for extreme swings in temperature on Mercury, face meltingly hot heat on Venus, and nasty planet-wide dust storms on Mars. But just like our planet, the rocky planets all have weather and climates of their own. Sometimes they're similar to what we have here on Earth, and sometimes they're more extreme. And speaking of extreme, check out our next episode to find out what the weather's like on gas giants.
All right, so that was a nice little introduction to terrestrial planets. So, astronomical unit explained. The term astronomical unit is used to measure distances in the solar system. From Sun to Earth is 1 astronomical unit. What is an astronomical unit?
A lot of people will say it is the distance between the Earth and the Sun. But strictly speaking, this isn't correct. Although we may think of the Earth as having a circular orbit, its orbit is actually slightly eccentric, meaning
It's an
the
ellipse.
distance to the Sun changes throughout an orbit, with the difference between the minimum perihelion and the maximum aphelion being almost 5 million kilometers.
Perihelion,
This
aphelion?
means that the International Astronomical Union has defined 1 AU to be the average Earth-Sun distance, calculated to be 149,597,870.7 kilometers. Bye for now.
So, yeah, astronomical unit. So, the first floating object in space, in vast amounts of nothingness, is Mercury. Mercury has the most extreme temperature range in the solar system, just like what you were saying, because there's no atmosphere to hold in. The sun is just going to beat down on one side and get it hundreds and hundreds degrees hot. But then as soon as it flips over, it's going to cool off dramatically. So the temperature range is 600 degrees. Mercury has a large iron core and the most craters. Why does that have the most craters? Well, it has no atmosphere to burn up any of the objects coming at it. It's close to the sun. So the gravitational pull of the sun is going to bring in objects towards it, like comets might get brought in. And when something strikes Mercury, that mark is there forever. Like that's going to leave a mark forever because there's nothing to erode it away. So it is filled with marks. So let's take a look at Mercury.
The planet Mercury is named after the messenger of the Roman gods, because even the ancients could see how swift and fleeting it is in the sky. But it wasn't until recently that scientists began unraveling Mercury's many mysteries. Mercury is the smallest planet in our solar system. Its diameter currently measures just over 3,000 miles, about the size of the continental United States. Like Earth, Mercury is a terrestrial planet with 3 main layers: a core, a mantle, and a crust. Only Mercury's crust has no tectonic plates. Also, its iron core is enormous by comparison, making up 85% of its radius, while Earth's inner and outer core account for just 55%. Because of the core's exceptional size, it's had a surprising influence on Mercury's overall size by causing it to shrink. The hot iron core has slowly cooled and contracted over the planet's 4.5 billion years. In doing so, it pulled Mercury's surface inward and has caused the planet to shrink radially by more than 4 miles. This shrinking planet is also the planet closest to the Sun, orbiting our solar system star at an average distance of roughly 36 million miles. Such proximity affects Mercury's atmosphere, or rather, the lack of one. It only has a very thin exosphere, which is traditionally the outermost layer of a planet's atmosphere. This exosphere is made of oxygen, sodium, hydrogen, helium, and potassium, all whipped up from the planet's surface by solar winds. The lack of atmosphere and close proximity to the Sun also makes Mercury a planet of extremes. The surface temperature can climb to 800 degrees Fahrenheit during the daytime and fall to 290 degrees below zero at night. Mercury's proximity to the Sun is also the reason behind its age-old reputation of being swift and fleeting. The Sun's gravity pulls harder on Mercury than any other planet, and like all planets, Mercury travels in an elliptical orbit, slowing down when it's farther away from the Sun and accelerating as it draws closer. Clocking in at an average speed of over 100,000 miles per hour, Mercury slings around the Sun in just 88 days. From Earth, Mercury is difficult to observe because it's fleeting and so close to the Sun. And so far, it's only been visited by 2 spacecraft, NASA's Mariner 10 and Messenger. Those missions gave us much of what we know today, but future ventures are in the works with high hopes of revealing more of Mercury's secrets.
Very cool. Venus, hottest planet. It's very similar to Earth in size and mass, but that might be kind of where it, well, maybe there are more similar things too. Has craters and volcanoes. Atmosphere is toxic and it is the hottest planet. It does have sulfuric acid clouds. The Russians sent a probe there, and I think it lasted 13 minutes. Not a very hospitable place. But could life be there? Possibly. Life as we know it on Earth? Doubtful. But the more that we look at the solar system and galaxies, and the more we understand Earth, life is everywhere on Earth. So when we're talking about other planets, we can assume, well, humans couldn't live there. Well, why does life have to be a human? Life could be in many, many forms that we don't even realize yet. So, Venus, let's give Venus a look.
Named after the ancient Roman goddess of beauty, Venus is known for its exceptional brightness in the night sky. But behind this facade is a world of storms and infernos unlike anywhere else in the solar system. Venus, the second planet from the Sun, is very similar to Earth from a distance, but up close, it's a very different world. Venus is about the same size as Earth, just slightly smaller. Its structure is also nearly identical, with an iron core, a hot mantle, and a rocky crust. The crust of Venus, however, is dotted with thousands of volcanoes, including Maxwell Montes, a volcano almost as tall as Mount Everest. Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. This pressure is heavy enough that a human standing on Venus's surface would be crushed. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit. making Venus the hottest planet in the solar system. Venus is so inhospitable, neither humans nor spacecraft are able to survive the planet's surface. But some scientists speculate that Venus wasn't always so unwelcoming. From roughly 2.9 billion to 715 million years ago, global temperatures on Venus may have been just a few degrees cooler than Earth's are today. And scientists theorize that the surface may have contained shallow oceans that could have held enough water to support life. Today, life may still exist in Venus's atmosphere. About 30 miles up in Venus's clouds, where the temperature and surface pressure are similar to those on the surface of Earth, scientists have observed strange dark streaks that appear to be absorbing ultraviolet radiation, a phenomenon that could be evidence of microbial life. Life may struggle to survive in the atmosphere of Venus, but it is this unforgiving environment that's made Venus an icon of beauty. It reflects 70% of all the sunlight that reaches the planet, which is why Venus shines more brightly than any other planet or star in the night sky. While more than 40 unmanned spacecraft have visited this infernal world, Venus, so illuminated in the darkness of space, still has much to reveal.
All right, Venus. Earth, our home planet, has abundant water and life, is geologically active, can support life as we know it. Most gravity of the terrestrial planets. Interesting. So we must have the most mass. So, Earth.
Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, in the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
Earth, thank goodness for water. Now, Mars. Mars is interesting. This is the one that we're going to really start to find out a lot about. Mars is a rocky red planet. Iron minerals give it its red hue. Once had liquid water, thin atmosphere, and large dust storms. So, where that ice is, I don't know. At some point, it's got to be liquid underneath it, insulated. If it has uh, a if it has a core, that core is going to be hot. So at some point, there's going to be liquid water on Mars. This is just me talking. And we have things in on Earth that don't need sunlight. We call them funguses. Mushrooms do not need sunlight to grow. You'll learn about that in seventh grade life science. But Mars, the one that's really going to change over the course of your lifetime, students.
To the ancient Romans, the planet Mars was symbolic of blood and war. But to many people today, the red planet may hold the key for a bright new future for humanity. The story of Mars began about 4.5 billion years ago when gas and dust swirled together to form the fourth planet from the Sun. Mars is the second smallest planet in the solar system, with a diameter just shy of the width of Africa. In fact, its entire surface area is similar to that of all of Earth's continents combined. Much like its terrestrial cousin, Mars is dense and has a rocky composition. At the center of the planet is a core made of iron, nickel, and sulfur, which may have created a protective magnetic field during Mars's earlier years. Enveloping the core is a rocky mantle made of silicate minerals and a crust rich in iron. These iron minerals react with the trace amounts of oxygen in Mars's atmosphere and rusts, giving the planet its signature reddish hue. While its blood-like appearance inspired the ancient Romans to name Mars after their god of war, the planet's rusty color could be considered symbolic of the planet's prime days long past. Today, Mars is dry, desolate, and cold, with temperatures dropping as low as negative 225 degrees Fahrenheit. But billions of years ago, the planet was much warmer, more geologically active, and had a watery surface. Lake beds and river valleys snake along the face of Mars, indicating that liquid water was, for a time, present. Volcanoes, such as Olympus Mons, the largest volcano in the solar system at 3 times the height of Mount Everest, once erupted lava. But by about 50 million years ago, soon after Earth's dinosaurs died out, Mars's volcanoes also went extinct. Water on the red planet still exists today, but mostly in the form of polar ice caps. Because of factors such as the presence of water, some scientists believe life may have existed on the red planet, and may exist again. Since the 1960s, space programs from around the world have launched missions to Mars in attempts to understand the planet's past, present, and potential for sustaining life. Life on another planet may well be out of reach for the near future. But if any planet could give us hope, Mars may hold the key to the survival of humanity.
Interesting. Mars. Summing up, Mercury orbits near the Sun, Venus is covered with clouds, Earth has abundant life, and Mars is a rocky planet. Mars is going to be the one that we're going to start to put things there permanently. We're going to start to build things there. Something that's just incredibly interesting. Um, if we ever need to leave our planet, Mars, they feel is a good possible option. Interesting. Terrestrial planets. Thank you, students.